Okay, so hello everyone. Welcome to this presentation on fuzzy models and information retrieval. Today we'll dive deep into how fuzzy logic is applied in information retrieval systems to enhance their performance and efficiency. By the end of this session, you'll understand how fuzzy models can deal with the ambiguity of user queries. Um, so before learning fuzzy models, I'll just give you a brief on the information challenges faced in traditional information retrieval systems. So traditional information retrieval systems have significant limitations. They expect users to formulate precise queries. However, in reality, users often express their information needs vaguely. For instance, if someone searches for data analysis, a traditional system might not retrieve documents that discuss data science or data analysis, even though these topics are closely related. So moving on to fuzzy models in information retrieval. So this is where fuzzy model comes into play. By incorporating principles of fuzzy logic, it addresses the issues of uncertainty in user queries. Unlike traditional models that classify matches in a binary fashion, the fuzzy model assigns degrees of relevance. This means that a document doesn't have to match a query exactly to be considered relevant. So moving on to fuzzy set, a fuzzy set theory is the foundation of fuzzy models. In the fuzzy set, elements have a degree of membership between 0 and 1. For example, if we consider a set called data analysis, in a document containing terms like data science might have a membership value of zero point 0.7, indicating partial relevance. This flexibility allows us to handle the vagueness inherent in natural language. Also, you can take the example of a fuzzy set of tall people. The person who is 6 feet will have a membership value of zero point 0.8, while a person who is 5.5 feet might have a membership value of zero point 0.5, depending on how tallness is defined. So there are mainly three fuzzy set operations, starting on with fuzzy union or the OR operation. The fuzzy set, the union operation or the OR operation takes the highest membership value among terms, making it suitable for broader searches. So, for example, as you can see over here, if there is a set A of hot weather with membership values such as follows, and a set B of warm weather with membership values of as follows. So the union of A is to B would be the maximum of zero point 0.7 and zero point 0.2 and zero point 0.7, which are the values over here and over here, which comes out to be zero point 0.7. Same for the A union values for 30 degrees, which is the maximum of zero point 0.6 and zero point 0.5, which is over here and over here, which comes out to be zero point 0.6. Next is the AND operation. The intersection operation or the AND operation uses the lowest membership value to define results. So it basically takes out the minimum of the two values. So using the same sets which were discussed in the previous slide, we can see that the A intersection values of A and B for 25 degrees is minimum of zero point 0.2 and zero point 0.7, which comes out to be zero point 0.2, and and the following for the other degrees as well. The third and the last fuzzy set operation is the fuzzy complement or the NOT operation. The complement operation or the NOT operation measures how a term does not fit within the test. So the formal characteristic of fuzzy model. Traditional models often assume terms are independent of each other. However, this isn't always realistic, especially in natural language. The fuzzy model improves on this by considering dependencies between terms using a correlation matrix. This matrix captures how terms co-occur in documents, allowing the system to understand nuanced relationship between words. So the formula for correlation factor is C of IL is equal to N of IL upon N of I plus N of L minus N of IL, where N of I is the number of documents containing the term KI, N of L is the number of documents containing term KL, and N of IL is the number of documents containing both terms Ki and Kl. So there are three steps for calculating for solving the fuzzy IR model. The first is is constructing the term correlation matrix. In this, the terms are extracted for documents and their co-occurrences are calculated. Next, calculate correlation factors to normalize these relationships. So the correlation factors for each of these term pairs are calculated. Thirdly, the user processes query using the fuzzy logic to rank documents based on degrees of relevance. So moving on with an example. So here we have three documents, which is shipment of gold damaged in a fire. Document two is delivery of silver arrived in a silver truck. Document three is shipment of gold arrived in a truck. And the query is gold silver truck. So we firstly extract all the keywords, which are shipment, gold, damage, fire, delivery, silver, arrive, truck. Then we build a term correlation matrix. So we map all the elements in a matrix format, and then okay. So now moving on with the examples, let's take arrived K1 and K3. So K3 is delivery and K1 is arrived. So as you can see, arrived is on two places. It is 1 and 2, and K3, which is delivery, is also in D2, which is document 2. So as you can see, there are two instances of delivery and arrived. So in the denominator we get 2, which is over here, and and arrived and delivery occur occur together only once. So we have in the numerator we have 1. So for the same for K1 and K5, so K1 is arrived and K5 is gold. So so the occurrences of arrived and gold together are in document 3, and the total occurrences are 3. So the answer becomes 1 upon 3. So accordingly, we fill the whole term correlation matrix. Then we map all the queries, which is K5, with query words, which are K5, K6, K8, with the all the keywords. Then we calculate all the correlation factor for each of these documents. For a document one, the 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 keywords in document one are shipment, gold, damaged, and fire, and the query keywords are K5, K6, K8. So we basically just take out all these values and we put it over here. For the correlation factor, we basically first first subtract the this number, which is over here, by 1, and we do it for each of these numbers, and then we multiply each of them, and the resulting answer we write it over here, which will become our correlation factor. So 1 minus 1 becomes 0, 1 minus 1 becomes 0, 1 minus half becomes half, 1 minus half becomes half. So 1 minus half becomes half, 1 minus half becomes half. So multiplying the answers of all that, we get the answer 0. So we do the same for all these query keywords, and then we negate the answer by 1. So 1 minus 0 becomes 1, 1 minus 1 becomes 0, 1 minus 4 upon 9 becomes 5 upon 9. So we calculate the same for document 2 as well, and the same for document 3. So we firstly map all the correlation factors in our matrix format, which is shown over here. Then for the query processing with fuzzy logic part, we firstly, if we have the query gold and silver, we take up the minimum operator. So over here, using gold and silver. So gold is over here and silver is over here. we take up all the minimum elements. So out of this, minimum is 1 and 0, minimum is 0. Out of D2, minimum is 5 by 9, and for D3, the minimum is 3 by 4. And on after that, we rank the matrix according to the descending format. So over here, D3 has the most value, so it is ranked first. D2 has the second most value, and D1 has the last value. So for the next query, we take up gold, silver, and truck. So over here, we also as the AND operator is present, we use the minimum operator. So over here, out of the three values, zero is the least, so we put over zero over here. In D2, 5 by 9 is the least, so we put 5 by 9 over here. For D3, 3 by 4 is the least, we put 3 by 4 over here. And as 3 by 4 is the highest value among these three, we put D3 first, then we put D2 first, then we put D2, then we put D1. Coming to the OR operator, so we over here we have the query gold or silver. We use the max operator. So firstly, we calculate the tuple. So over here, out of these three, one has the most value, and after that for D2, out of the three, one has the most value, and for D3, one has the most value again. So as you can see, the all of these three have the same values, so we can rank it anyway. Firstly, coming to the advantages of the fuzzy model, there are several benefits to using the fuzzy models in AI systems. They handle vague and imprecise queries by supporting partial matches, which improves the relevance of search results. However, this ability makes them useful across various domains, from academic research to e-commerce. Coming to a disadvantage of fuzzy models, fuzzy models come with the challenges. They require significant computational resources due to their complexity, which can be a drawback for large-scale systems. Additionally, turning the membership functions to optimize performance can be subjective and require expert knowledge. Thank you.